Hello everyone, welcome to this video lesson. In this video lesson, we wrote the Lyman series in hydrogen spectrum. We know the energy of an electron, it's the total energy of an electron in Bohr's orbit E is something like minus or else minus 13.6 z square by n square. As electron in different orbits will have different energies. When electron jumps from higher orbit to lower orbit, it emits energy. That energy is emitted like a photon. That photon will have a wavelength. That 1 by lambda is called wave number. And we have derived equation for this wave number as Rydberg constant of 1 by n1 square minus 1 by n2 square. n1 and n2 are the principal quantum numbers. If n1 equal to 1, n2 equal to 2, 3, 4 onwards till infinity, the corresponding wavelength emitted will be in ultraviolet region and the spectral lines are called something like a Lyman series. Now we want to identify what are the wavelengths of this Lyman series. The first possible Lyman series is electron jumps from second orbit to first orbit. That's the least possible jumping, least energy. As the energy is least, E equal to h nu or hc by lambda, corresponding wavelength is maximum. So we can write from the above equation that 1 by lambda maximum of the Lyman series is Rydberg constant of electron is jumping into the first orbit from its immediate second orbit. Rydberg constant of 1 minus 1 by 4, that is 3r by 4, that's 1 by lambda maximum. It implies lambda maximum is 4 by 3r. This is one possibility. The next extreme possibility is electron is jumping into the first orbit, but from the highest orbit, that is n2 is infinity. The respective energy will be maximum because this electron is jumping from the highest orbit. Automatically wavelength is minimum. So again from the similar equation, I can write 1 by lambda minimum is Rydberg constant of 1 by 1 square minus 1 by infinite square. That is Rydberg constant itself. That implies lambda minimum is Rydberg constant itself. If you calculate this value, it will be around 1212 angstrom, and this lambda minimum is around 912 angstrom. Both of these are before the visible region, so the respective wavelengths are in ultraviolet region. Lyman series is always in the ultraviolet region. We can also calculate the ratio of maximum wavelength to minimum wavelength in the Lyman series as maximum is 4 by 3 r, minimum is 1 by r. So the ratio is nothing but equal to 4:3. But the spectral lines of the Lyman series are not visible to a human because they are before the visible region. Now, if you want to draw a diagram of the spectral lines for this Lyman series, we can do that. Electrons are always jumping into the first orbit, n1 equal to 1 to the higher orbits. N2 equal to either 2, 3, 4, or even from the highest orbit, infinite. If electron jumps in all these cases from these, so this is the least energy or the maximum wavelength, like we have shown here, and this is the maximum energy or the least wavelength, like we have shown here, and everything will be there obviously in between. This is what you mean by Lyman series. From different orbits, electrons are jumping into the first orbit. This is called something like Lyman series, and this falls in a ultraviolet region. That's it for this video lesson. The next video lesson we will be talking about a Bohr series. Thank you for watching.